Okay, so we're continuing to talk about matrices, and I want to talk a little bit about using the calculator in the matrix. So actually, I can just show you this. I'll just pull up my calculator here. Calculate the calculator's matrix functions. You can see right here. There's the word matrix. Well, that's a pretty good indication that that's where you want to go. So if you go to second matrix, then that brings up this menu. We have 3 columns here. If you want to just call up a matrix, then you just go to names and you just select whatever matrix you want to work with. If you actually need to, well, this math column, we're pretty much not going to do anything with that. The edit column is where you actually enter the values to define a matrix. So like in the one that we were just looking at, which was a 2 by 3, 2 columns, 2 rows, 3 columns. We go to edit. Let's say that's matrix A, and you see right here it says 1 by 1. So I need to change that to 2 by 3. And notice when I did that, it automatically filled in all of these cells here. Now our matrix is going to be 2, 4, 8. That's row 1, and row 2 is 3, 1, and 7. Okay, now we've named matrix A. We've designated matrix A to be the matrix that we're interested in. Okay. And if I wanted to call it up, I would just go to names and hit enter, and then there's matrix A. And if I hit enter again, then it will actually bring up the matrix. Okay. All right. Now, if I want to access a particular element, this slide is talking about how to do that. So let me work through that on the calculator as we read the instructions. So from the home screen, press second matrix names to access matrix A, and that brings up our matrix. Now, if we want to get to a particular element, I do this. I go second matrix A parentheses, and then I enter the subscript of the matrix. So like I know already that 3 is right there, but that's in the second row, first column. So that would be in 2, 1. And now when I hit enter, this should show me 3, which it does. So if you need to pull up a certain entry, that's how you do it. Okay. And in the example here, I pulled up the entry 2, 3, which is 7. All right. Our next thing to talk about here is matrix multiplication. So to multiply 2 matrices is a little bit more complicated than multiplying just numbers. Now we all hopefully are pretty familiar with just multiplying real numbers. But when you have one matrix multiplied by another matrix, it's a bit more complicated. And so you can just skipping down to this example down here. Here I've got one matrix being multiplied, two by 2 matrices being multiplied together. And you might wonder, well, how do we do this? Do we just multiply this times this, and this times this, and this times this? Well, unfortunately, it's not quite that simple. It's sort of an involved process. The good news is that in your actual work, you're just going to let the calculator do your matrix multiplication. But let me briefly explain how this works, okay? And let's read through the definition and then we'll actually do it. So the product element, Cij, so Cij would be like this, like that's C11, is found by multiplying each element of the ith row of A, so the ith row of A, that'd be row 1, by the jth column of B, which in this case would be right there, and then adding the results. So there's kind of a lot going on there, so I multiply row by column and then add the results, and then that would give me the entry for the first slot here. So I'll actually just perform that on the whiteboard so you can see what that actually looks like. let me write down the matrices. That's 2, 4, 3, 1. 2, 4, 3, 1. And negative 1, 2, 3, negative 2. Okay, so I want to multiply these two matrices, and I'm going to need some space to do this. But, so as I said, we multiply row by column. So, you know, this is by the way, there's kind of a lot to talk about here. This is a 2 by 2. This is also a 2 by 2. The idea of dimension is also important when you're multiplying matrices, because sometimes you just can't do it. So there are matrices that cannot be multiplied by one another because they're not the right size. So you have to have you have to meet certain dimension requirements. And I'll talk about that in a moment. But in this example, those requirements are met, and so we can do the multiplication. So here's what we're going to do. So this is going to give us a 2 by 2 product. So you just know that in advance. The first element that we've already talked about, that's going to be row 1 times column 1. So row 1 times column 1 is going to be 2 times negative 1 plus 4 times 3. And then I'm going to figure out what all that is. This, by the way, is called the linear combination. But so that's negative 2 plus 12, which is 10. All right, so that's A11. I'm sorry, this is C. We were calling that C. So this is C11. What about C12? So I take the first row times the second column. So first row is 2, 4. Second column is 2, negative 2. So that's 2 times 2 plus 4 times negative 2. That's 4. And this is negative 8, so that's a negative 4. This is C21, so that's 3, 1 times negative 1, 3. So that's 3 times negative 1 plus 1 times 3. And that is equal to negative 3 plus 3 is 0. And finally, C22, 3, 1 times 2, negative 2. So that's 3 times 2 plus 1 times negative 2, which is 6, minus 2 is 4. And after all that work, we have our matrix, which is, let me get rid of all the other stuff here. That's 10 minus 4, 0, 4. So that's actually what happens when we multiply two matrices, and that's where this number, or this 2 by 2 matrix comes from. Okay. So I was talking about dimension requirements as far as what matrices could actually be multiplied. Let me specify that. I could multiply these two matrices together because they were the right size. What size that is this. The product you can only get the product if the number of columns of A equals the number of rows of B. So in other words, when you're multiplying these two matrices, if this one is n by m, let's say that that's A, then whatever matrix B is, in order to actually do the multiplication, it has to be m rows by something. It doesn't really matter what the number of columns are for the second matrix, but the number of rows, these two have to be the same. Okay. So n by m and m by whatever. So if you think about like, okay, well, what are some matrices that we could or couldn't multiply? So I could multiply a 2 by 3 and a 3 by 4. I could multiply that, and it would, and the other thing is that what this would give me is a 2 by 4 matrix. Or I could multiply a 2 by 2 and a 2 by 1, and what that would give me would be a 2 by 1 matrix is the product. So this is just some notes about the sizes of the products that you're going to get and what products you can actually multiply. Now, why can't you multiply matrices, excuse me, if the number of columns of the first doesn't equal the number of rows of B? Well, if you actually try to do this row column multiplication to two matrices that aren't the right sizes, you'll see why. Basically what happens is that you end up trying to multiply one row or one column by something that's just not there. So there's just no entry there, and so you can't do it. So that's why. Okay. So, that's why matrix multiplication is kind of weird. Another thing to point out about matrix multiplication that I don't think I have a slide for this particularly, but I just do want to mention it, is that matrix multiplication is not commutative. So, note, matrix multiplication is not, if you remember your math words, commutative. Now, what does that mean? We're really used to thinking of multiplication as always being commutative. So we always think, oh, 3 times 4 is 12, and 4 times 3 is 12. So 3 times 4 equals 4 times 3, right, for real numbers. But for matrices, this is not true. So matrix A times matrix B, in general, is not necessarily equal to matrix B times matrix A. Okay, now there do exist matrices where it does happen, but in general the rule is that you don't expect this to be true. Okay, so matrices that commute are sort of a special kind of subclass of matrices. All right, but in general they don't commute. So that's sort of yet another weird thing about this. Okay, so let's get back to talking about multiplication, and here's the good news. I'm going to now show you how to multiply matrices in the calculator the easy way. So if I want to put these two matrices into the calculator and multiply them, let's do it. First things, I have to enter them. So I'm going to have to redo matrix A. Matrix A is going to be 2, 4, 3, 1. So that's a 2 by 2. And it's happened to be the same numbers. That makes life easy. 2, 4, 3, 1. So I don't have to change the numbers. Then I have to go back to the matrix menu and go down to B. And, whoops, I did the wrong thing. I have to go to the edit menu. I'm sorry. Edit, choose matrix B. And this is again a 2 by 2. Oh, and see, I messed up. Sorry. 2 by 2. And that's -1. Make sure you use the negative and not the minus. Okay. And now I've got my matrices entered. 1, -1, 2, 3, -2. And again, make sure you use the negative sign here, not the minus sign. And now I'm gonna multiply them. So here's what we do. It's this easy. You go to matrix names, call up A, multiply. Just hit the multiply button, then go to matrix B, select it, and then just hit enter. And all that work that we just did can be summed up in this little situation right here. Now, if you try to multiply two matrices that are not the correct size, not the correct dimension, then basically the calculator will just get mad at you and say, I think it says dimension error or something like that, but it won't do it, and that's why. Okay. All right. So that's some stuff about matrix multiplication. From here, we're going to get into talking about some matrix definitions. Let me pause the video and we'll start these definitions in the next video.